Hello, in this video, we will have a small introduction to linear algebra. Linear algebra is a fundamental subject in undergraduate mathematics, providing essential tools for a variety of academic and professional fields. This presentation offers an overview design specifically for beginner students, focusing on foundational concepts to build a, a strong understanding. Key topics including linear equation, matrix, vector spaces, and transformations. By the end, you will appreciate the importance and applications of linear algebra across science and engineering disciplines. Linear equations and systems. Definition of linear equation. An equation where each term is either a constant or the product of constant and a single variable. For example, 2x plus 3y equals 7. Systems of linear equation. Multiple linear equations considered together define a system. The goal is to find variable values that satisfy them simultaneously. General form expressed as, you can see the equation here, where coefficients and variables are combined linearly. Matrix and vectors. Matrix definition. A matrix is a rectangular array of numbers arranged in rows and columns such as 1, 2, 3, 4, 4 2 by 2 matrix. Vector definition. A vector is a special matrix with a single column, often representing direction or magnitude in space. Matrix operation include addition, scalar multiplication, and matrix multiplication, where dimensions must align to multiply matrix. Solving linear systems using matrix. Metric representation, Gaussian elimination, solution types. If we take metric representation, what is the systems can be expressed as ax equals b, where a is the matrix of coefficient, x the variables, and b the constants. Gaussian elimination, a step-by-step process using raw operations to simplify matrix and find solution. Solution types. Depending on the matrix form, systems may have unique, infinite, or no solutions. And vector spaces. Definition. A vector space is a collection of vectors where addition and scalar multiplication are defined and satisfy specific axioms. Example. Common examples include R square and R3, the set of all 2D and 3D vectors as well as a polynomial and function spaces. Linear independence, a set of vectors in linearly independent if no vector can be found by a linear combination of the others. Linear transformation. The definition of linear transformation is a linear transform maps vectors from one vector space to another while preserving vector addition and scalar multiplication. Representations such as transformations can be represented by matrix illustrating how input map to outputs. Kernel and range. The kernel is the set of vectors mapped to 0. The range is the set of all possible outputs, both crucial to understanding the transformation. Eigenvalues and eigenvectors. Concept, characteristical equation, applications. And if we take the application used in stability analysis, diagonalization, and many scientific fields to simplify matrix operation and analyze systems. And the summary of this is recap key concept included linear equation, systems, metric operation, vector spaces, transformation, and eigenvalues. And what's the importance of this linear algebra forms the backbone of fields like engineering, physics, computer science, and data analysis. Next step, explore textbook, online courses, and practical applications through projects to deepen your knowledge. And thank you. See you.